Okay, so let's try another word problem, continuing on here with exponential functions. If every 7 years the population doubles and the starting population is 123, what is the population after 35 years? Okay, so I can come up with this function, y equals 123 times 2 to the x over 7. All right, here's where these numbers come from. So 123 is my number when x equals 0. Because if x is 0, then I'm going to have 2 to the 0 over 7, which is 2 to the 0. Anything to the 0 is 1. So my starting number is always this number here that goes in front of that base with the exponent. Okay. Now, the reason I have x over 7 is because I want to find a way so that I don't double the first year or the second year or the third year. I want to make sure I don't double my number until I hit the number 7. Okay, then I'd have 2 to the 7 over 7, or that's 2 to the first. I would be doubling my number at year 7. After 14 years, if I wrote the number 14 in here, then I would be doubling the number twice, because I would have 14 over 7, 2 squared, so I'd be multiplying by 4. I'm doubling that number twice. Okay, so to answer the question, if I want to know how much or what the population is going to be after 35 years, well, my 35 goes here. And think about, if I double the number every 7 years and 35 years goes by, how many times does the number get doubled? Well, it gets doubled 5 times, right? 35 divided by 7 is 5. Okay, so you'll see these formulas written a couple of different ways. I hate for you to memorize the formula, right? I just think it is better if you understand where the numbers come from. You're really much better off. Okay, so the formulas you might see are this one and this one. You can copy them down. But K, in each case, is the time needed to multiply the initial number by B. Okay, the initial number in this problem was 123. We're multiplying by B, remember doubling the number was 2. K is the amount of time needed to multiply by B. So go ahead and write that down if you need to. I'm not a huge fan of those formulas. All right, so here's a half-life problem. Now in chemistry, I'm thinking you would have learned about half-life where you have certain, let's say, radioactive chemicals. They cut in half. They have a half-life. That's the amount of time that they take to cut in half. All right, so in example 8, the half-life of an element is 15 minutes. How many times will it cut in half in 25 minutes? Let's answer that question first. Okay, so the answer to that question is 25 over 15. You could, of course, reduce this. Or 1 2/3 times. So if you think about this, if I've got 25 minutes, I'm going to cut in half after the first 15 minutes. And then I'm not quite going to cut in half again, because that would take me to 30 minutes. So what I have here is 25 divided by 15, or 5/3 of the time. That's how many times it's going to cut in half, and that's what your exponent is going to be. So now let's answer the second part of this question. If 50 grams were present to start, how much is there after 10 minutes? All right, so I'm going to type the starting amount. This is half-life, so I'm cutting everything in half. I'm multiplying by 0.5. Now I have to think about what the exponent is going to be. Okay, so after 10 minutes, I haven't quite cut in half all the way yet. Okay, what I've really only done is an exponent of 10 divided by 15. Okay, I'm only 2/3 of the way there. So the amount that I have left then is y equals 50 times 0.5 to the 2/3. We could reduce that. All right, so that concludes the lesson on section 4.1, exponential functions. So now I'm going to give you a big chunk of problems to do. Please do these. You're going to have tomorrow in class to do them as well. And, then we will see what we can do here from there. Please do odds only, and you may certainly work with a partner or in a group. Try to be mindful of whether or not you should be using a calculator. They may or may not give you specific instructions in the book, but the next time you have a quiz, you'll have some with a calculator, some without a calculator. All right, I hope to see you soon.